Hi, Doc Revis here with a short lecture on predicting products of double displacement reactions. Here's an example of a double displacement reaction, HCl plus sodium hydroxide neutralization. Step 1, you assign the charges. In this case, these are all monatomic charges, so they all have +1 or -1. So we have hydrogen with a +1, chlorine with a -1, sodium +1, hydroxide -1. You assign these by whatever conventional means you use for assigning charges. Note that all compounds start with the electropositive part first. It's always plus minus when we have compounds. Step 2, regroup according to your plus minus. Group the inside elements and the outside elements. And remember to place the positive element first, or whatever the positive species is, place it first. So regroup these for the inside outside, again following the plus minus convention. Step 3, crisscross the charges so you get your final compounds. Crisscross the charges and reduce if appropriate. And then, if necessary, balance the equation. In this case, there was no need to balance it. By the way, HOH is H2O. Here's another double displacement reaction where we have a divalent element. Calcium has a +2. We can see when we assign the charges here. Silver fluoride, silver with a +1, fluorine to -1, calcium +2, and chlorine -1. Again, assign these by whatever conventional means you're used to assigning them. And we regroup them inside with the outside, put in the positive charge first, and we regroup it, and we get silver chloride and calcium fluoride. And then, as necessary, balance. In this case, balance out with a 2 and a 2 in front of the silver fluoride and the silver chloride. The next one is double displacement with a polyatomic anion with sign of charges. In this case, boron has a +3 and fluoride has a -1. Sodium with a +1 and sulfate, SO4, has a -2. We regroup the inside with the outside again. Then we crisscross the charges. In this case, the sulfate sends its -2 to the boron, and boron sends its +3 to the sulfate. We form the appropriate compounds with the positive ion first and the negative species polyatomics. In this case, sulfate second and fluorine second, and we rebalance and we get the final products shown.